G'day everybody, I hope everyone's well. So in this video we're going to talk about rear main seals in in-depth detail. So in my last video you would have seen I dropped the gearbox out of my Patrol in order to redo my rear main seal. So when I had the engine out about a year ago, a bit more, I put a new rear main seal in, but I didn't do correct measurements. In fact, I didn't measure at all. I was just, put the seal in, it's going to work. And yeah, it didn't work. So this video is hopefully going to show you that seals are not just this simple install it's going to work every time thing. There's quite a lot of engineering involved behind them, and it takes a lot of preparation for them to work correctly in the environment that they're installed in. So, what is a seal? So there's a couple of different types of seals that we can talk about. So the rear main seal itself is what's called a lip seal. So a lip seal is known as a dynamic seal, two different types, static and dynamic. So a static seal is any kind of seal made of whatever it is, metal, rubber, plastic, that is clamped between two unmoving objects. So the best example of a static seal would be a valve cover gasket. It's simply squished between the valve cover and the head itself and creates a seal to stop oil seeping out. A dynamic seal, however, seals around a moving component. So a rear main seal being that, the rear main seal is knocked into the seal housing, which is static and is bolted to the back of the engine block. And then the crankshaft which it seals around is constantly moving, meaning that it is a dynamic seal. Dynamic seals have a bit more engineering behind them in order to work, which we will talk about because, as I said before, I made the mistake of assuming they were a simple seal, installing one and it failing on me. So, the rear main seal is what's known as a lip seal. A lip seal is a dynamic seal made out of rubber. It has a rubber lip element. When installed, this rubber lip will seal around the crank. There is a bit of flex built into it because it is a rubber lip. However, there is also a sealing spring around it, which creates tension around the lip to hold it around the shaft and stop any potential leaking bypassing the lip. Part of the lip seal design which makes them effective is that because the lip faces towards the engine, every engine will have some proportional amount of blow-by from the combustion process. Blow-by into the crankcase creates a positive pressure, and in this case, the positive pressure will aid in the lip sealing onto the crankshaft because of the area on the inside of the lip seal compared to the outside of the lip seal. Okay, so now's the time to remove your gearbox. If you've watched the last video that I made, you'll know how to drop a gearbox out of a GU Patrol. That being said though, this video will cater to any rear main seal, providing it's a lip seal. So all you got to do is rip your clutch off, rip your flywheel off, and we'll go from there. So now that we've got the flywheel off, lighting's a bit poor in this situation. I'll try and zoom in. So what's happened is, you can see there's oil here, and what it looks like is that instead of actually leaking past the lip element on the speedy sleeve, it's been bypassing here in the speedy sleeve, because on the back of the crank, I'll cut in a photo, inside where the crank sits onto this face here, there was oil, so that makes me assume that the oil was bypassing the inside diameter of the speedy sleeve on the outside diameter of the crank, which would make sense. The plate just lifted off. All you have to do is break the silicone seal. See on the back there, silicone seal that I've made up so that the water can't, or if you go through a river, water won't get behind the plate and push itself through the rear main into the engine. But yeah, it looks like that was the problem. Well, there's the problem there. the speedy sleeve is pulling itself off as I'm prying this off. The speedy sleeve should be a press fit onto the crank. So that's probably where the problem's stemming from. So now that we're looking in the light, what you can see is that the speedy sleeve itself has pulled off with the assembly. So the problem is here, well, the obvious problem, the speedy sleeve is meant to be press fit onto the back of the crank. So it seems like the last owner that put the speedy sleeve on, the reason why, well, assume it was leaking oil from the original rear main seal without the speedy sleeve, so he threw one of them on it, but yeah, he clearly didn't pick the right sized one. And so what I'm going to do now is I'm going to try and pull out the seal. Might need a pry bar of some sort, and we'll inspect the speedy sleeve and the rear main. So I've set up my rear main seal housing on a machine vise that I made as one of the components of my TAFE. Normally, if you're pulling out one of these seals, you can sit the housing straight down and use like a seal pulling tool and rock it, and it'll pull the seal up like that. You go around it. But in this case, I want to try and preserve the lip element, because I want to see if the lip element was actually malfunctioning and not sealing properly. As well as that, I want to be able to visibly identify the sealing area on the lips, on the speedy sleeve itself. So I'm going to flip it over, sit it in my vise as so, and I'm going to use a screwdriver on the back side of the seal, which hopefully work, and I'll punch it out with a hammer. I have bought a new seal housing, but it's always a good idea to try and preserve your components as best you can. So now, if we wipe everything off, we'll slide the sleeve out, and let's take an examination of this lip here. So in most cases when you run a speedy sleeve, you'll press it on and it'll stay there for the life of the vehicle. But it's pretty clear in my case that that was not happening. So with the rear main seal I put in when I had the engine out, what looks like has happened, let's see if I can get the camera to focus on it. And what I think's happened is it's ridden itself up on the back corner radius up here on the speedy sleeve, and it's dug into this groove here, you can hear that, and that's caused damage to the seal, and in turn caused a seal failure. However, I think what's also to blame is the fact that the speedy sleeve wasn't a press fit, meaning that there was ability for oil to bypass. And considering that my engine is pretty old, it breathes kind of heavy, there's a lot of blow-by, and there's reasonably high crankcase pressure, it was just pushing past the loose speedy sleeve. Okay, so an extremely high recommendation of mine would be to go out and source yourself a surface plate. So a surface plate is a completely uniformly flat or almost uniformly flat plate. Surface plates are used in any engineering sense where precision measurement is required. You can get granite surface plates or cast iron surface plates. I preferred the granite one because it's not going to corrode, it's not going to rust. So a good surface plate is surface ground almost perfectly flat. The difference between the highest and lowest points on the surface plate should be smaller than 2 microns, which is 0.02 of a millimeter, also known as a bee's dick. And it just makes precision measurements, or even just measurements in general, much more precise and much more satisfying, because there's a few tricks you can use this plate for. So one of the first tricks that you can use this plate for is gauging audibly if a piece that is meant to be flat is indeed flat. So the way you do this is you sit the piece on the plate and then you just tap it around with your finger. So if you get any kind of clicking or feedback sound from the workpiece, this will in turn tell you that the piece is not flat, because if the piece was perfectly flat, there wouldn't be any high spots allowing the piece to rock back and forward and create the audible sound. The next really good trick that the surface plate allows you to do is utilizing what's known as engineer's blue. So this is blue dye. It's a thick oil which is mixed with a blue, I think it's Prussian blue dye it's called. And this is marking out blue, which is used for anything where contact is gauged. So for instance, you can put it on one metal part which comes into contact with another metal part. You put them together briefly, take them apart again, and the leftover blue will show you where the two parts have contacted. So all you got to do is smear a big handful of bearing blue around on the surface plate. The ideal thickness you want for the bearing blue is just enough so that if you touch it with your finger, you can just see the blue on your fingerprint, but you can't see the blue all over your finger. If you can see the blue on just your fingerprint, I believe the rule of thumb is about 0.5 mm thickness. So with the blue spread out nicely, we're going to rub around our rear main housing, and I'm going to do that now. And as you can see, once I pull it up, there's perfect uniform blue all over the ceiling area on the rear main housing. So this in turn tells us, because it's a new piece, that it is perfectly flat from factory, so passes my QC inspection. Okay, so before we take any measurements of the crank journal, we're just going to give it a polish. Using 1000 or 1200 grit emery paper should be fine. A trick to polish up round journals or anything round with emery paper is you get two pieces, you sticky tape them together in the exact outside diameter, you put them on, and then you use a little bit of string, you wrap it around once or twice, and then you can go left and right with it, which will spin the emery paper around and polish the whole crank journal evenly. If you do it by hand, just with one piece, this will be more than fine. It's okay to do this. Just try and polish the same amount on both sides. There's not really much of a chance of creating a high spot because it is only 1000 or 1200 grit paper, but it's just good practice to always try and evenly polish any sealing surface. So for all of our measurements, you can see here I'm using the back of my bench vise. I took all these measurements again once I had the surface plate. I just used a vernier with the depth gauge off the back of it. You can probably use a steel ruler or whatever you want, as long as your eyes are good enough to see the measurements. So the first important measurement that we're going to take is the rear main seal housing. The rear main seal housing has this little tab in it, which the back of the rear main seal sits against, and this moves the whole position of the rear main seal outwards. In this case, the tab sits 4.5 mm up from the rear of the housing. The next one, the rear main seal, we're going to measure. So the overall length of the rear main seal is 8.45 mm, and then the length from the front of the seal to the rear lip element is 4.5 mm. If you really want, you can measure your speedy sleeve as well. However, the measurements for this aren't going to be accounted for in the stack height calculations. Finally, the rear crank journal. So there's two visible marks in this crank journal. The first one being 15.55 mm from the front of the journal. This is quite a deep groove. You can pick it up with your fingernail if you run over the top of it, so it's more than 0.1, 0.2 mm deep. The second one is just barely visible. You can't feel it with your fingernail. So if we take our overall measurement of the length of this crank journal and you take away the 15.55, which is the measurement from the front to the deep groove, this will give us the remaining length, which is 8.43 mm. So 8.43 millimeters. If we are to determine whether this groove is indeed caused by a rear main seal, we'll take the 4.5 millimeters, which the rear main seal housing spaces the seal out at, and then we'll calculate the overall length of the rear main seal, take away the length from the front to the rear lip element, and the remainder of this is 4 millimeters. So 4.5 millimeters plus 4 millimeters equals 8.5 millimeters, and this is almost perfectly accountable for the 8.43 millimeters that we have calculated. So I have reason to believe that this groove has been caused by a previous rear main seal. What's most likely happened is there's been a rear main seal on this crank that's been on there for so long that the rubber has worn down, and the actual spring that holds tension on the lip has started digging a groove into the crank journal, which has stuffed it up. And so what would have happened is the last owner saw this, decided that putting a speedy sleeve on was the easiest fix, and yeah, making a mistake and not putting the right one on. So how are we going to fix this? Well, some people would say that this crank is now stuffed because you can't fix it. The only way to fix it is to get a new crank or somehow get it welded and machined back. But there's a much easier way to fix this. And what we're going to do is we're going to move the position of the seal so that it rides on a nice new polished section of the crank. So what we're going to do is we're going to make a ring which sits behind the seal, sits against the spaces on the rear main seal housing, and moves the position of the seal. So if you really wanted to, you could get a lathe and machine up a ring which perfectly sits in there. However, because I was doing this job on the weekend, I had the next best thing. So I used my big angle grinder with the cutoff wheel, and I cut a ring out of the old rear main seal. The rear main seal itself is composed of a metal endoskeleton and then a rubber outlining on this metal ring. With the rough ring cut out, I then used a flapper wheel, which I carefully polished down the ring until it was almost perfectly 2 millimeters uniform thickness all the way around. This is quite difficult to do. There's probably a much better way to do this, or a much better material to do this. But this is what I used, and it was good because it was almost the perfect right size, and when you pushed it into the rear main seal housing, it didn't fall out. It was nice held there. So with the ring made, you can press that into the rear main seal housing. Just make sure that you've polished up any potential contaminants, so you've taken any burrs of metal off or anything that could compromise the new rear main seal. So press this one in and bottom it out against the tabs on the rear main housing, and then you should be good to push the new rear main seal in on top of it. 2 millimeters of thickness is going to shim our whole rear main seal out from the damage on the crank journal to a nice new polished section of crank. Once your seal's knocked in, just have a bit of a gander at it, have a look around, and make sure everything looks like it's seated correctly against itself. You can see with my rear main seal here, because this is meant for an RD28, the place that makes them, I believe it's Golby's Parts, they pack them with rubber grease. And also just throw your eyes across the front of the rear main housing with the seal in it and make sure the seal looks like it is seated flat in there. If it's on the slightest bit of an angle, it may not matter, but it's always a good idea to have it perfectly 90 degrees as possible. So once you're happy with how your rear main seal sits, you can clean up the back of your engine block where the housing is going to sit, because you're going to need to use gasket maker, and then you can start throwing the gasket maker on your rear main housing. I've always used the red stuff for oil pan sumps and rear main housings. I'm sure there's a better gasket maker to use, but this stuff's always worked for me, so this is the stuff I use. You need to throw a big bead all the way around the back of the housing, and then a little bit of a bead underneath the housing where it's going to connect with the sump gasket. If I could do this job again, it would probably be a much better idea to undo quite a few of the sump bolts and rock the sump down a bit when you put the rear main seal back on, just because it was almost impossible for me to push the rear main seal on with the sump gasket there. When I ended up pushing the rear main seal on, folding the lip past and getting it onto the journal, it pushed the sump gasket in a bit, and I had to use a self-tapping wood screw and screw that into the rubber gasket a tiny bit just to allow me to pull it back and align the bolt holes so I could get the bolts into the bottom of the rear main housing. But apart from all of that, it's a relatively easy job. It's better than taking the whole engine out. Do your bolts up and you can start torquing them up to the sequence after you've let the gasket maker dry for about an hour. And then it's full steam ahead, cleaning everything up. So whenever I've installed plates like this, I always use gasket maker when I'm sealing them to the engine. A lot of people say you don't need to do this. I've always thought it's just good practice because you don't want water getting into your clutch and your bell housing. It's strange because some cars, I've just done the 4Runner and that has drain holes and direct pathways for water to get into the bell housing. Whereas with the RD28, if you actually use gasket maker on the intermediate plate, there's no pathways for water to get into the bell housing, providing you've sealed the boot around the clutch fork. So with the intermediate plate mounted now, we can throw on the flywheel. The flywheel's quite heavy, so be careful when you're lifting that up. When you put the crank bolts in, you need to put some anti-seize up in the top corner of them to lower the friction coefficient. And you need to put some Loctite on the actual threads so there's no chance of them working themselves loose as the flywheel operates. So the flywheel bolts get 157 Newton meters of torque. Do it in 3 separate stages, so go 50, 100, then 157 Newton meters with the torque wrench. Be careful when you do it, make sure that you wear safety glasses, not up on your forehead, on your face like they should be. And try and brace the flywheel with a pry bar or something in one of the teeth on the ring gear. It's a bit scary, sometimes it jumps off, so be careful. Make sure you do some stretches before you do it, because yeah, it's quite hard on your back. So, with the flywheel mounted, you can start to clean up your clutch. I didn't have an RB25 clutch alignment tool. I used the fancy King Chrome clutch alignment set. Gotta say, I'm not a massive fan of it. It's a bit of a fiddle to get it together. However, it does work, and it did work for me without much of a problem. That being said, it's a bit more intricate than just using a normal clutch alignment tool. But once it's aligned and you're happy with how it looks, just throw it back on the flywheel, locate it with a bolt, and then do up all the bolts and put the right torque setting into them. Okay, so we're coming to the end of another video. So I'm not going to include the assembly procedure for putting the gearbox back in because it's fairly straightforward. It's pretty much the reverse process of how it was in my strip down video. If anyone needs any help doing any jobs or has hit a hurdle, they're more than welcome to comment on this video or message me directly on Instagram. I'm always happy to help in any way, shape or form. I hope this video is useful to everyone. This is a fair bit more intricate than most of my other videos. If people like this video format, where I'm actually filming but also voiceovering and getting more into detail rather than just talking into the camera while I'm doing the job, feel free to let me know in the comments, leave a like, subscribe, and more content's on the way. So with all that being said, I hope everyone's well. I'm going to leave you to it. Don't do anything silly, don't drop flywheels on your feet, and I'll see you all in the next video.